morning guys, I hope we are well. In this lesson we're going to be focusing on rearranging formulae where factorising is required. Alright, so the first thing we're going to do, we're going to make x the subject for these three equations. So feel free to pause the video if you like, or if not, just listen to me explain it now. Okay, so 3x plus 2x equals y. We want to make x a subject, so we just want x on its own. At the moment I've got an x here and an x here. I should be able to spot right now that I have a pair of like terms. So 3x plus 2x gives me 5x. So 5x equals y. If I divide both sides of my equation by 5, that tells me that x is y over 5. Okay, and that is my solution. Okay, not too difficult. However, what happens if I have something like this? So 3x plus bx equals y. First of all, notice how similar the question is. Instead of a 2, it's turned into a b. How does that affect my outcome? Well, the first thing I'd done in my first question was I collected up my like terms. So I'd done 3 plus 2. So in this question, wherever I do 3 plus b, that tells me I've got 3 plus b lots of x equals y. Do we see that I've actually just factorised this? Because I've taken the factor of x out of both of these terms and put it outside of the brackets. You're probably more used to seeing the x in front of the brackets like this. That's fine, they mean exactly the same thing. But either way, do you see how this is just an algebraic version of what I just done? So instead of 5x, I've got 3 plus bx. Okay, so how do I get from x times by 3 plus b equals y to just x on its own? Well, how do I get rid of a multiplied by 3 plus b? I'm going to do the opposite. I'm going to divide both sides by 3 plus b. So that tells you that x equals y all over 3 plus b. And this is my solution. Okay, so let's try the third one. Do we notice again it's very, very similar to what we just done? Instead of 3x now, I have ax. So, because x appears twice, if I factorise it, look how helpful this step is. So I take out my common factor of x, and I've got x lots of a plus b equals y. Think really carefully, why am I factorising here? Well, I want to make x the subject. If I want to make x the subject, I need x to appear on my page or screen just once. By factorising, it just makes it look a lot more simpler. Okay, so now I can divide my left-hand side and my right-hand side by a plus b. So that tells me that x equals y all over a plus b. Okay, so really, when you have multiple terms with the same variable, we need to factorise. So that basically means, that's a fancy way of saying, if I have x here and an x here, if you factorise it, that just turns it into 1x. Yeah, and that makes it a lot easier to just get x on its own. So when x appears multiple times, factorise. So for your task 1 today, I would like you to pause the video and have a go at making x the subject of these 4 equations. And in a few seconds, I'm going to cut to a video of myself going through the solutions for every single one of them. Alright, so for question 1, I would like to make x the subject. At the moment, x appears multiple times in my equation. To deal with that fact, all I'm going to do, I'm going to factorise the left-hand side. I'm going to pull out a common factor of x. So if I put x outside of my brackets, that tells me inside my brackets I would have a plus b, and my right-hand side stays the same. I have not touched that yet. Alright, so I've got x times a plus b equals 2y. I just want x on its own, so I'm going to divide both sides by this bracket. So if I divide my left-hand side and my right-hand side by a plus b, my left-hand side will just become x on its own, which is what we want. And my right-hand side is 2y, all divided by a plus b. And this is my final answer. Alright, let's try question 2. I just want x on its own. I'm trying to make x the subject. That divided by 2 has no reason to be there. So let's deal with that first. So if I multiply both sides by 2, so do my inverse operation, that tells me that I have ax plus bx equals 2y. Do we see that now in that one step, this question now looks exactly like question 1. So just to remind you, in question 1 I factorised, so I pulled out a factor of x, so x times by a plus b equals 2y. So I factorise my left hand side,
and then I divided both sides by that bracket to get 2y all over a plus b. And that is my final answer. So it's the same as question 1, just written in a different way. So for question 3, I'm going to show you 2 ways you could have solved this. So both of these are absolutely fine. Either answer is correct and they are both equivalent. Okay, so the first thing you might have wanted to do is factorise the left-hand side. So this is one way you could have started. So pull out a common factor of x on my left-hand side. That tells me that I have x lots of a plus 1/2 b equals y. Okay, so now just to get x on its own, I'm going to divide both sides by this bracket. So if I divide both sides by a plus 1/2 b, so divide by a plus 1/2 b, that tells me that x equals y all over a plus 1/2 b. And this answer is true, and I'm going to show you another way you could have done that. Okay, so some people might look at this and think, that fraction looks a bit messy, so they might want to multiply both sides by 2. So to get rid of a half, I double it. So I'm doing the opposite of halving number, I'm doubling it. So if I multiply both sides by 2, well, my right hand side would be easy. 2 lots of y is just 2y. Okay, we've got rid of that half, so this just becomes bx. But be careful, we need to multiply every term by 2. So this ax would become 2ax as well. So 2ax plus bx equals 2y. Okay, at this stage, so you might want to factorise. So take out a common factor of x. So that tells me I've got x lots of 2a plus b equals 2y. Now, what I could do, dividing both sides by that bracket, so if I divide by 2a plus b, divide by 2a plus b, that tells me that I have x equals 2y all over 2a plus b, and this answer is also true. So both solutions are acceptable. This fraction is equivalent to that fraction because the numerator has been multiplied by 2 and the denominator has been multiplied by 2, but either of these answers is absolutely fine. Okay, last one, question 4. See, I have an x here and an x here. So how can I turn these two x's on my page into one x on my page? Well, if I factorise, like what we said, take out a common factor of x, that tells me that I have x lots of a plus 2b, and that equals y. To get from x times by a plus 2b to just x on its own, I'm going to divide by this bracket. I'm dividing both sides by a plus 2b. Which tells me that x equals y all over a plus 2b. And this is my solution.
Okay, so sometimes we're going to run into more challenging equations to rearrange. So let's say we're asked to make x the subject of these 3 equations. Do we notice how these are different to the questions that we just done? So now there's x's on my left hand side and x's on my right hand side. I'm about to cut to another video of me solving these 3 problems. As always, if you want to just try them for yourself, please do. But in a few seconds, you're going to see these full solutions.
Alright, for question 1, I need to make x the subject. At the moment, there is x's on my left hand side and there are x's on my right hand side. Can you think of an easy step I could do to make it so there are only x's on one side of my equation? Well, if I subtract 2x from both sides, watch what happens. That will eliminate one set of these x's. So I take away 2x from my right hand side and take away 2x from my left hand side. 3x's take away 2x's give me one lot of x, and 2x take away 2x gives me nothing, so I'll just be left with 2y. And in one step, I have solved the problem, and x is now the subject of my equation. Question 2. Alright, this one's a little bit more tricky. Okay, at the moment, there are x's on both sides of my equation, but I want to make x a subject. Ultimately, I just want x equals something. So I can't have x's on both sides of my equation, so I need to sort that out. Can you think of a step so that I can make it so there are only x's on one side of my equation? Well, if I subtract bx from both sides, so if I eliminate this term, so subtract bx from my left hand side and my right hand side, watch what happens. My left hand side will be ax minus bx, and my right hand side, because I subtracted that positive bx, I'm just left with that 2y. Do you see why that step was helpful to me? Because now there are only x's on my left hand side, so that's taken me a tiny bit closer to just getting x on its own. I've still got a bit of work to do, but I've sorted all of my x's and pushed them all onto one side. Okay, at this stage, thinking back to earlier on this lesson, I'm going to factorise. Let's pull out that common factor of x. So x lots of a minus b equals 2y. In this one crucial step, I've gone from having two x's on my page to just one x on my page. And that's getting me closer to my goal, which is just to have x on its own. I can get to my goal in one step. How do I get from x times by a minus b to just x on its own? Well, if I divide both sides by a minus b, so divide both sides by a minus b, that'll tell me that x equals 2y all over a minus b. That is my final solution. Okay, question 3, getting a lot trickier now. So, think about what we're trying to do. We want to make x the subject. We just want x on its own. At the moment, I have x's on my left-hand side and x's on my right-hand side. Can you think of one step I could do to make it so there are only x's on one side of my equation? Okay, the way I'm going to start this, I'm going to eliminate this positive bx. So I'm going to take away bx from the right-hand side and take away bx from my left-hand side. So that will give me ax minus bx plus z equals, well, I got rid of the bx, so I'm just left with 2y. Okay, it's not looking great yet. However, do you see that I've gone from having x's on both sides of my equation to now just x's on one side of my equation? Okay, so that was helpful. Does that positive z need to be there? Well, no, it doesn't. I'm going to subtract z from both sides of my equation. Okay, because I've got rid of this positive z, I'm just left with ax minus bx equals 2y minus z. So what I've done, I've pulled all my x's onto one side of my equation and I've gotten rid of anything that doesn't contain an x. Now I'm ready to factorise. Factorising my left hand side by pulling out that common factor of x. That's going to give me x lots of a minus b is equal to 2y minus z. One more step to go until I've reached my goal. I want to make x the subject, so I just need x on its own. How do I eliminate that multiplied by a minus b? I'm going to divide by a minus b. I'm going to do the inverse operation. So dividing my left hand side and my right hand side by a minus b, that tells me that x equals 2y minus z all over a minus b. This is my final answer.
Okay, so at this stage, please can you pause the video and find task 2 on your worksheet, and just please, as always, just let me know if you need any help with any of these problems.